Hello. Hi. Welcome back. Hope you're enjoying your pizza. I know it's been a long day, but this is the last thing that we have to do, okay? I promise. And half of it is, lab work time. Okay, so if you catch my meaning. But we're just gonna go ahead and finish up our final lab today. Okay, and this lab is gonna be a little bit fast-paced, just as a little precursor, and it's gonna go over all of the classifications that we've just talked about. Okay, so before we do that, I just want to make sure that no one has any questions about these classifiers. Like everyone understands them, everyone kind of knows how they work, right? Okay. Great. So that means I did a good job, or that means I did a bad job, and you guys are doing a great job filling up the space. Either way, it's good. So let's go ahead. I'm going to share my screen, and we can go ahead and start with the lab. Okay. Once again, this is posted in the tinyurl.com/Bentley resources, BNR capitalized. Okay, same doc, page 3. So this should be there. If it's like has trouble saving and stuff like that, please let me know. I'll just try and figure that out on the fly. But yeah, let's go ahead and get started. So once again, we're going to import our iris data set. So go ahead and do that. And then same as before, we're just going to load everything into the X and Y variables, right? So we can then create the new cell and then loop through everything and then put it into a combined data set, right? It's 150, yeah. And then right, so we do the same kind of combination that we were doing before, making sure everything's combined to one data set, just so that we can do the shuffle and everything, right? Okay, and we can see it worked out very well, so that's good. And then we can go ahead and split this back into X and Y, right? So or actually just do X. And then for posterity's sake, we'll just print out X and Y. Okay. And oh, yeah. Let's see. Really quickly, I'm going to add a cell before we split it back. Just the same shuffle cell that we did before. Okay, so you can copy paste the cell if you want, but it's the same like import random.seed 0 and then random.shuffle data. Okay, make sure you A, run that once, and B, put it before you split the data back up, just so everything is corresponding. Does that make sense? And then yeah, so and then it'll shuffle everything hopefully in the same way and provide that output. So we're going to stop there really quickly, wait for everyone to catch up. Once you've printed out your X and your Y, you're set for now. That's where we are. All right, how is everyone getting along? Are we close to having our X and Y set up? It's good, good, yep. Looks good. All right, so now we're gonna go ahead and we can start with the first of our different classifiers, okay? So what really quickly was our first classifier and what was the principle behind it? In as few words as possible. Yes, please.
Decision tree and try to or high purity scores, low impurity scores.
Correct. So our first classifier is the decision tree, and our goal is to get actually 0 impurity score. But yes, as low impurity score as possible. And the way we do that is by building a flowchart, or like a binary tree, I guess, so to speak, in order to make these decisions. Hence the name decision tree, right? So what we're gonna do is we're gonna go and grab the decision tree classifier from sklearn, and we're gonna go from sklearn.tree import decision tree classifier. We're gonna instantiate it, and then we're gonna use the dot fit on our X and Y. Okay, so same as before. In fact, most algorithms that come from sklearn will use this dot fit method in order to fit it. And you just need to instantiate, whatever different type of algorithm you want to use. Okay. There should not be like a what's it called? An error or warning from this. It should just run as is, right? And the way we're gonna visualize, this decision tree is we're gonna use something called matplotlib. Has anyone ever heard of matplotlib? Good, good, okay. So we're gonna use matplotlib in order to visualize this tree and plot all of the information in it, okay? So we're going to first import matplotlib.pyplot, and we're gonna call it PLT to make it easier. And sklearn itself actually also has a plot tree method or function, whichever you prefer. And so we're going to plot the tree, and then we're just gonna save it to something like tree.png. So just a simple path, right? And it's gonna take a little while to save and plot because it's a little bit large, but now you can see here, this is how it builds the splits, right? So let's wait for everyone to get to the plot. Yes. Oh yes. So it's just these 2 blocks. Okay. That's okay.
When I was running it.
Much like me better because of pineapple.
I was literally first on the
Oh, well, it just likes me better, I guess. Okay, does everyone have a plot built up? Okay. So I know the text on the plot is a little bit small, but if we kind of zoom in and examine it, okay, you can see the first split is X, like the third, or technically the 4th column, which is petal width, I think, is less than or equal to 0.8, right? And that splits off 50 samples and it leaves 100 other samples. Okay. And the next split is whether or not it's less than or equal to 1.75. Okay. And then that splits off these 54 samples against these 46 samples. Okay, and that's how the computer will build out these splits. So it always picks the, so to speak, best possible split, which isn't necessarily always a split of 0 impurity, but hopefully most of the time it's very close to 0. And then it takes that and it keeps splitting until we have Gini impurities of 0 across the board. Okay, and then once it has that, it can use this very simple flowchart in order to determine. So like, let's say we gave it let's say we gave it a new data set where x of 3 is greater than 0.8, so we'd go right. It's less than or equal to 1.75, so we go left, and then so on and so on, and it will be able to give you like exactly what class it is. Okay, and the way we can do that theoretically would be to use clf.predict. And you can go into the documentation and find all of these functions and methods, but you know, essentially all you have to do is, you know, build that test data set and then have it predict as per usual. So the next classifier, yes, okay. The next classifier is the random forest classifier. It's just a bunch of decision trees at once, right? And for that, because of that, I guess, we're going to import the random forest classifier from sklearn.ensemble, because that's where it is. And then we're going to call it the same CLF equals random forest classifier. And same thing, clf.fit. CLF equals clf.fit. X from, we'll just fit it on everything except the last 5 terms. Okay. And then do that. Okay. And I forgot to run that cell. And the reason we're going to take out the last 5 terms for now is we're going to use that as a what's it called? As a test data set. Okay, just for now. And so what we can do after that is we can do clf.score. Clf.predict just gives you predictions. Clf.score gives you everything. And we can score on everything from the last 5. Right? You can see it does perfectly. That's a rarity. It's not so, usually AI algorithms aren't supposed to do perfectly and probably won't do perfectly. But because our data set is relatively small, and we're also only testing on five other samples, we see that we're actually doing very well. And so that's a little, I guess, sneak peek at the power of all of these different classifiers. And if you're using them correctly in the correct use cases, you can have some very powerful AI applications, right? And so it's another, I guess it's another achievement, right? Congratulations, you've built your first perfect AI application. Great job. Okay. So our next classifier is the support vector machines. And so support vector machines, maybe you can remember that we mentioned talking about like various different kernels, and all of these different kernels are going to be listed in scikit-learn's documentation. And you can also actually use just the default kernel. So let's go ahead and do that first. So from sklearn.import, or from sklearn import svm. Same thing, classifier equals svm.svc. SVC, by the way, stands for support vector classifier, I think it is. That's why it's different or weird. And then same thing, fit it on X and Y. Okay. And why not? We can do scoring in the same cell as well. And so you can once again do like, say, take out the last 10 elements and score it. Or you can experiment with like various different train test sizes. So like you could take the last 20 elements or the last 5 elements or something, right? And just see how that works with performance. That's something I recommend you try if you have maybe spare time at the end of the lab work block. For this one, you can see it's like 0.56. Okay, so it's definitely not perfect. It's not great. And the reason is because this SVM by default uses a linear kernel. So right now it's using a linear splitting line, if that makes sense. And so we can see that our data can't really perfectly be split by a linear kernel. So what we can do instead is we can say something like this. So reinstantiate this with a different kernel. So let's call the RBF kernel, right? And then we can do the same fitting and the same testing. And this. And so once we do that, we can kind of see how this kernel might compare to the default linear kernel, right? And it's actually relatively similar. So both of these do actually they're the exact same, which is very interesting. But both of these do maybe slightly above average job. So in this case, what you would do is you probably go to the scikit-learn documentation and look for maybe other different kernels, like a Gaussian or yeah.
Putting it on for last time, or
Sorry.
aren't they being, like, on the one above, or we did it? The minus five is that. So are you doing? I think it's yourself for last time.
Oh, that's a typo. Good catch. Good catch. It should be reversed, yes. You're very correct. But in some senses, I guess I did my own exercise of experimenting with the fitting. So yeah, now it's 0.9. Now it's a lot better. And this one should be very similar as well. Yeah, 0.9. Actually, exactly. That's very interesting. So you can kind of explore like what various different kernels might do, how they might impact, performance. And if you want, you can also read into these kernels a bit more. They're really just different types of functions, but you can consider it. And then this last one, the naive Bayes classifier, KNN will actually save for the lab itself. But let's go ahead and do the naive Bayes. So from scikit-learn once again, we can import what's called the Gaussian NB or Gaussian naive Bayes model, and we can instantiate it and fit it as per normal. Okay, and then same thing, we can score it on, maybe not itself, but something like that. And you can see it does about similar, it does 90%. So all of these classifiers do relatively well, with the exception of random forest being perfect. They'll do the exact same. It's very interesting. All right. Has everyone seen all four of those models? They're doing relatively well, right? They're all more or less workable. Okay. So now